Namaskar, I am Anand and you are watching Join for Education. In this class, I am going to discuss about probability, which is one of the most important chapter of mathematics. So, in this chapter, we shall discuss about event and algebra of event, axiomatic approach to probability, additional theorems on probability. So, these are the learning point of this chapter. So, event and algebra of event, axiomatic approach to the probability, additional theorem on probability. Let's discuss one by one. Event and algebra of event. For this we need the help of experiment. An operation which can produce some well-defined outcomes is known as experiment. There are two types of experiment: deterministic experiments and random experiment. So in deterministic experiments, an experiment which gives the small results every time, which when it is repeated under identical condition is called deterministic experiments. Random experiments. In our daily life, we perform many experimental activities where the result may not be same when they are repeated under identical condition. When a fair coin is tossed, it may turn off a head or a tail, but we are not sure which one of these results will be actually obtained. Such experiments are called random experiments, thus rolling an unbased die, drawing a card from a well-shuffled pack of cards are all examples of random experiments. An experiment is called random experiments if it is satisfies the following two conditions. It has more than one possible outcomes. It is not possible to predict the outcomes in advance. So there is no problem to understand the event and algebra of events. So after there is no problem. If you want to take the short skin, then you can take it. So this is the event of and algebra of events. So we have no problem to understand the event and algebra of event. Let's discuss about axiomatic approach to probability. Let's discuss about outcomes and sample space. A possible result of a random experiment is called its outcome. The set of all possible outcomes in a random experiment is called a sample space, and it is generally denoted by as sample space as equal to all possible outcomes. Suppose a die is thrown and let A be an event getting an odd number, then A equal to 135. Now if the outcome of experiment is 3, then we can say that event A has occurred. Suppose in another trial outcome is 4, then we can say that event A has not occurred. So a possible result of random experiment is called its outcome, the set of all possible outcome. In random experiment is called sample space. It is generally denoted by S. Therefore sample space equal to all possible outcomes. After there is no problem to understand up to this step. Let's discuss about types of event. Events can be classified into various types of the basis of their elements. Sure events, the whole sample space S is also a subset of S, so it represents an event. Since every outcomes of an experiment carried out a member of S, therefore the event represented by S is called a sure for a certain event. Sun rises in the east is a sure event. On tossing a coin, either head or tail will occur is a sure event. On throwing a die, we have sample space hash equal to 1, 2, 3, 4, 5, 6. Let E equal to event of getting a number less than 6, then E equal to 1, 2, 3, 4, 5, 6. So E is a sure event. Impossible event. The empty set phi is also subset of the sample space S, so it represents an event. Since there is no element in the empty set, therefore it cannot occur. That is why event phi is called an impossible event. On throwing a die, we have the sample space as equal to 1, 2, 3, 4, 5, 6. Let E be event of getting a number less than 1, then E equal to phi. So E is called an impossible event. After there is no problem to understand the sure event and impossible event.